Have you ever wondered why all planets are perfectly round? And what if these celestial bodies decided to break the rules and change their shape? Would we end up with square planets, triangular moons, or maybe even intergalactic shapes we can't even imagine? Well, let's find out. So how do planets form in the first place? The universe is filled with swirling clouds of dust and gas. These clouds, called molecular clouds, consist of various elements and compounds, such as hydrogen, helium, carbon, oxygen, and so on. They're like a cosmic kitchen filled with the ingredients needed to cook up some brand new planets. The first step in the recipe for planetary formation is called the accretion theory. Let's say that something happens that causes gravitational instability, like a supernova goes off nearby or something. This pushes the gas and dust in the cloud and causes them to come together. Because of gravity, these particles start falling toward a central point. They become more tightly packed together, like when you squeeze a ball in your hand. And eventually, they're squeezed so hard that the cloud starts to flatten into a disc shape, kind of like when you mix flour and water to make pizza dough. This disk is called a protoplanetary disk. It's also spinning because the cloud's particles had some rotation to begin with. Now, imagine these tiny dust particles and gas molecules dancing around in the disk. Sometimes they bump into each other, and when they do, they stick together like Velcro. These little clumps of dust and gas are called planetesimals. They're the building blocks of planets. And as the planetesimals continued to collide and merge, they grew larger and larger, forming protoplanets. The protoplanets were getting serious about their size, and their gravity became stronger. Some of them got so massive that they became the grand masters of their cosmic neighborhoods, the planets we know and love. Each planet had its own unique recipe of gases, rocks, and sometimes even water. But why do the planets look like spheres? Well, it's all because of gravity. Let's go back to our protoplanets. Imagine you're squeezing a balloon with your hands. The air inside of the balloon pushes back, creating pressure. Something similar happens with planets. Gravity squeezes its material inward, pulling in towards the center. And since gravity acts equally in all directions, it pulls material from all sides toward the center of mass, resulting in a sphere-like shape. And that material pushes back with pressure, resisting the force of gravity. In the end, they both find a sweet spot where they balance each other out. It's called hydrostatic equilibrium, a fancy term that means everything inside a planet is in balance. But that's not all. Another thing that makes the planet spherical is their rotation. Think about a ball of Play-Doh or something like that. Imagine you spin it rapidly. The material starts to push outward, making the Play-Doh bulge at the equator and flatten at the poles. The same thing happens to planets. As they spin on their axes, the combination of gravity and rotation pushes the material outward, making the planet bulge at the equator. They low-key want to become disks again. However, gravity doesn't want any lumpy planets. It wants them to be nice and round, so it keeps pulling on the material, trying to make everything as compact as possible. Eventually, gravity wins, and the planet settles into a spherical shape. Let's take some examples from our planetary playlist. Jupiter, the giant of the solar system, loves to show off its oblateness. It spins so fast that it becomes noticeably squished at the poles and chubby in the middle. It's like a spinning top with a cute belly. Saturn, the ringed wonder, also joins the oblate party. It spins around with its beautiful rings, and its oblateness is even more pronounced than Jupiter's. These examples show how rotation can give planets a unique shape. They go from being perfectly round to having a delightful bulge around the middle. It's like cosmic pottery, where the spinning motion creates a playful and distinct shape. So now you know why the planets are round. But what's more interesting is, what if they weren't? What if they were, let's say, cubical, or even triangular? Well, let's see. A cube-shaped or a triangle-shaped planet would have its mass spread out in a completely different way than a sphere. And you know what that means? Gravity would be all shook up too. On a spherical planet, gravity pulls everything towards the center because the mass is evenly distributed around that center. But when we introduce a cube-shaped or triangle-shaped planet, things get interesting. If you're standing at the center of one of those faces, you'd feel the strongest pull of gravity. That's because the faces are the closest to the center of gravity. And as you venture away from the center and start walking towards the edges, gravity starts playing tricks on you. You would feel the struggle against the steep-angled gravity. Walking on those edges would feel just like climbing a mountain or walking on a super steep slope. All because gravity wants you right in the middle of the face and nowhere else. Now imagine the terrain along the edges and corners. It's a barren, rocky, and dry landscape. Why? Well, all the water would pool in at the center of each face, leaving the edges high and dry. And the air quality? Well, it's either non-existent or so thin that it can't support life. Not the coziest place to set up camp, that's for sure. And don't forget your warm clothes, lunch, and hiking boots. You'll need them because of the crazy climate. The type of climate you'll encounter on our cube or triangle-shaped Earth depends on how it spins. If it rotates at its corners, each side would enjoy a mild, temperate climate. However, if it rotates on an axis through two of its faces, things get intense. Picture a roller coaster version of our current climate. Some faces would be polar wonderlands, icy and chilly. The top and bottom faces for the cube, and the bottom face for the triangle. Meanwhile, the other sides would be completely different. In a cube, they would be scorching hot with an equatorial climate that would make you break a sweat. Instead of sunlight gently curving along the surface, it would directly beam onto these faces. Talk about feeling the heat. And on a triangular planet, the sunlight would strike the faces at an angle. This angled sunlight would create fascinating temperature variations across the planet. Imagine this. As you move from the base of the triangle towards the tip, the temperatures would gradually decrease. The base, where the sunlight hits most directly, would be the hottest region, just like the equatorial climate we're familiar with on our spherical Earth. But as you venture towards the tip, the angle of sunlight would be less direct, leading to cooler temperatures. But the base is still super cold and dark, since the sunlight doesn't directly reach it. So the triangle would be absolutely crazy in terms of temperature changes and climate zones. By the way, you know that cozy blanket of air we call the atmosphere? Well, on our angular Earth, things would get a little topsy-turvy. Gravity would be pulling stronger from the center of each face. The result? The atmosphere would go through some crazy changes. Picture this. At the center of each face, where gravity is strongest, the atmosphere would gather and thicken. It would be like a bustling city, full of air molecules. But as you venture towards the edges, things would start to thin out. The atmosphere would become scarce and very thin. So breathing along the edges would be quite a challenge, and the edges would be a tough neighborhood for life to thrive. Moreover, a thinner atmosphere means less protection from the sun's radiation and solar winds, so corners and edges would be extremely dangerous for humans. Of course, this is all just a playful exploration of what could be. Our Earth loves its spherical shape, and that's a good thing. But there's no harm in imagining wild and wonderful possibilities, so keep your imagination soaring and continue to marvel at the marvels of our amazing planet, however it may be shaped.
84 million years ago, many modern mammals, birds, insect groups, even the first flowering plants are already there. Dinosaurs are still roaming around. They have around 20 million years left before the asteroid. T-Rex, a fearless hunter, becomes the king of the dinosaurs. In the Earth tilted by 12 degrees. Picture our planet as a chocolate truffle. The shell is hardened, the center is viscous, with semi-solid matter. Its top layer, the crust, consists of tectonic plates that are like puzzles. Continents and oceans come on top of these plates. 84 million years ago, the mantle and the crust started rotating around our planet's outer core, then going back. If you'd been able to see it from space, it would have seemed like the entire planet has tipped over on one side. Today, it would have moved New York City to where Florida is. Let's say our planet is like a spinning top. It whirls perfectly if the weight on the top is evenly distributed. But if you move some of the weight to one side, it makes it tilt. It may have been caused by the moving of the tectonic plates and one of them sinking under another. We might be drinking water older than our solar system. Some scientists think the water we have on Earth may have come from ice specks that were floating in some sort of a space cloud more than 4.5 billion years ago. Lakes aren't always peaceful and relaxing. They can also explode. It happens when there are volcanic gases under the surface that can burst, rise to the surface, and cause big damage. The Earth's rotation is slowly going through time. Every year, The moon gets a little bit of energy from our planet and slowly drifts farther away from it. These two things are making our day longer, but really slowly, around 1.4 milliseconds every 100 years. That means when dinosaurs were around, the day was 23 hours long. Our planet used to be purple. One theory says ancient microbes didn't rely on chlorophyll to absorb the sun, but on different molecules. They absorbed green light and then reflected back a nice purple color. Every time you take a dip in the ocean, remember you're swimming above more than $700 trillion worth of gold. Not on the ocean floor waiting for someone to get it out, but in tiny particles dispersed in the water. The deepest place on our planet is the Mariana Trench, a spot in the Pacific Ocean, 36,201 feet under sea level. But the deepest place that's not covered in the ocean is in Antarctica. Technically, it's hidden below thick and deep layers of ice, goes more than 8,300 feet below sea level. There are 60 tons of dust falling from space to our planet every day. You probably inhale a pretty good amount of this cosmic dust while just going to work. It's dust, small particles from comets, meteorites, and some other space bodies. Dalal, Ethiopia, is the hottest inhabited place on our planet. Between 1960 and 1966, the temperature was 106 degrees Fahrenheit, and even in the wintertime, the temperature goes up to 98 degrees Fahrenheit on average. 8 minutes and 20 seconds. That's the time sunlight needs to travel from the sun to our planet. It's still not that much compared to what it takes for the light to reach Pluto. 5.5 hours. Almost 70% of the fresh water we have in this world is held in ice sheets and glaciers. More than 96% of the total amount of water on Earth is in the oceans. The Earth is like some sort of big magnet. Its inner core is actually a sphere made of solid iron, with liquid iron surrounding it. All those variations and changes in density and temperature create some sort of force, which makes the iron produce electrical currents. They are lined up by the planet's spin, and together, they create a magnetic field. There are many stars in the Milky Way, 100 billion, but way more trees on our planet alone, around 3 trillion. You can tell how old the tree you're looking at is by its rings. They can also tell you more about the conditions of a given year, too. When these rings are thin, there was a drought, while the thick ones say it was a rainy period. Earth is a magical planet where even rocks can walk, at least some of them, in Death Valley, California. They leave trails so you can record the path they've passed. Some of those biggest rocks have left tracks behind up to 1,500 feet long. Smooth-bottomed rocks wander around, while those with rough surfaces tend to leave straight tracks. The world that surrounds us consists of atoms, and they seem to be solid. But 99.99% of them are just empty space. An atom is just a really small nucleus and a cloud of electrons surrounding it. These electrons are particles, but they act like waves. They don't exist in one point but are spread over a range of probabilities and occupy lots of space. Take the empty space in our atoms, and all the humans could fit in a really tight space like the volume of a sugar cube. Australia is slowly shifting north, 2.75 inches per year because of tectonic movements. Australia is one of the top continental tectonic plates that move faster than others. You'd need 400,000 moons to reach the level of brightness the sun has. Sounds a lot at first, but the moon only reflects the light coming from the sun. It doesn't make its own. And even though that's not enough, its brightness depends on the exact angle between the sun, moon, and the Earth. The planet we live on used to have 2 moons, or at least some scientists believe so. They figure the side of the moon that faces the Earth is relatively flat and low, while the other side is way thicker and crustier. The theory says that there used to be the second moon that collided with the thicker side. Some believe there's still a second moon. It could be not a giant space body we see clearly in the sky, but some sort of a small asteroid pulled into the Earth's orbit. Air doesn't mostly consist of oxygen. Almost 78% of it is nitrogen. If you want to see some pretty steep rocks, go to Canada, Auyuituk National Park. It has the biggest vertical drop in Canada, the tallest and the steepest cliff, with 105 degrees of overhang and 4,000 feet of rock. A team of 4 American men finally made it to the top in 1985, although there were 30 attempts for that before. It took them 33 days to get up. The Pacific, Atlantic, Indian, and Arctic are the 4 world's oceans. The 5th is confirmed to be the Southern Ocean. It's not defined by the continents around it, but by its Antarctic current that goes from west to east. Research shows this current was created more than 30 million years ago when South America and Antarctica had separated. This allowed water to flow around the bottom of the ocean without any barriers. Melting glaciers and ice sheets means more water in the oceans. It adds the extra weight of all that liquid pressing down the sea bottom, making it sink. The Earth's surface looks solid and kinda permanent, but every 500 million years, it goes through a process of regeneration. Tectonic plates crash into each other. Continental crust creates pressure on the oceanic crust, and that pressure activates the volcanoes. Through time, all this results in regenerating and replacing a majority of the Earth's surface, just like our body regenerates skin cells, replacing old with new ones. Out of all planets in the solar system, Earth is the only one with the outer crust that's broken up into huge surfaces we call tectonic plates. This is an important process that allows the formation of oceanic trenches and mountains, and also helps with protecting the Earth. When microscopic planets that live in the ocean are gone, they fall down to the bottom. The remnants go back into the interior of our planet and get recycled, and eventually end up in the atmosphere, protecting us from overheating and turning into Venus, the hottest planet in our solar system.
So get this, the Earth acquires 40,000 tons of mass every single year. More and more people are being born, new buildings and structures. You might think that's something that adds mass, but nope, since it's created out of existing matter on the Earth, it's actually dust falling from space to our planet. That dust consists of vestiges coming from our solar system, like space bodies that never managed to form into a planet, or asteroids and meteors that fell apart on their way and now drifting around. Our planet is there like a giant vacuum cleaner that pulls in all those particles of dust powered by gravity. So yes, Earth gains weight, but some calculations also say the entire planet, including the atmosphere and the sea, is losing around 50,000 metric tons of its mass annually. Gases like hydrogen and helium are within our planet's atmosphere, but they're so light gravity can't retain them there. So huge amounts of those gases escape our planet every year. 6 pounds of hydrogen every second. Sounds like a lot, but the Earth is really heavy, so it would take trillions of years for all the hydrogen to escape our atmosphere. Also, the planet's core is like some sort of big nuclear reactor. It runs all the time, so it gradually loses energy, which means it's losing mass too. Our planet is not a perfectly shaped sphere, it's more like a squashed one. As it spins, gravity is directed toward the Earth's center, while a centrifugal force goes outward. Earth has a tilted axis, so centrifugal force doesn't exactly oppose gravity. Also, gravity pushes those extra masses of Earth and water up at the equator into a bulge. Earth also has a waistline, 24,900 miles. You weigh more standing at one of the poles than at the equator. Although, for weight loss, Pluto comes as the best option. A 150-pound person would weigh around 10 pounds there. Avoid Jupiter, the same person would weigh over 350 pounds there. Our planet is all green and blue now, but chances are it used to be purple. Scientists think ancient microbes might have used some other molecule to harness the sunlight instead of chlorophyll that gives plants their green color. That molecule possibly colored the living organisms into a more violet shade. The Earth is electric. Just one stroke of lightning can heat the air to over 50,000 degrees Fahrenheit, which causes the air to rapidly expand. That same ballooning air makes a shock wave we know as thunder. 6,000 lightning flashes appear all over the planet every minute, and the longest one occurred in the sky above Brazil, 440 miles long. Newer studies found out that the Earth's core is as hot as the sun's surface, over 9,300 degrees. The driest spot we have is the Atacama Desert of Peru and Chile. The center of Atacama has spots where we've never recorded any rain. The coldest place is naturally Antarctica, where winter temperatures can go down to minus 100 degrees Fahrenheit. No thanks. It's also the biggest desert we have on Earth. We imagine deserts as endless, sandy, and insanely hot areas, But there are coastal, subtropical, and polar deserts. They all have windswept and barren lands, which makes them very difficult for animals and plants to inhabit. The Pacific Ocean is the Earth's biggest ocean basin, which covers a huge area of almost 80 million square miles. The Pacific contains over half of the free water on our planet, and is so big all of our continents could fit there. Earth used to have 2 moons, or at least that's something scientists believe. That second one was almost 3 times smaller than the one we have today, and may have orbited our planet before it slammed into the bigger one. This clash may be an explanation of why the 2 sides of the moon we're left with is not equal. And there are moonquakes going on. It looks pretty inactive from our perspective, but the ground there is definitely shaking, although less than on Earth. Moonquakes shake at great depths, especially midway between the lunar center and its surface. To get to the longest mountain chain, we have to look way down under the surface of the Atlantic Ocean. It's a chain of volcanoes that goes about 18,000 feet above the bottom and spans over 40,000 miles. We have a magnificent planet, more than 4.5 billion years old, which makes it 10,000 times older than humans. But it's not the same as it was in the beginning. The ground we walk on is recycled. Earth has its cycle. Magma from the depths of our planet comes up and hardens into rocky matter. Tectonic movements brings the rock to the surface where erosion happens. That's a process where wind, water, and other natural forces break apart rock and changes it. The small pieces get buried, deposited, and compacted into sedimentary rocks like sandstone. If these rocks are buried deep enough, they get cooked and transformed into magma. So the whole cycle repeats all over again. We got used to seeing lava and ash coming out of volcanoes, but some of them even produce their own flashes of lightning. In 2020, the Taal volcano, which is around 40 miles away from the Philippines' capital, Manila, started blasting smoke and ash pretty high into the air. Inside its ash column, small pieces were colliding and then producing lightning flashes people could see scattering across the sky. Lakes can go crazy and explode too. Neos, Manoon, and Kivu are 3 lakes that sit above volcanoes. Since there's magma under their surface, there's carbon dioxide released into the lakes, which leads to a deep gas layer above the lake bed. It's pretty rare, but carbon dioxide can suddenly erupt from the lake and form an unpleasant gas cloud, similar to something a volcano does. 70% of our planet's surface is covered in oceans, but we've only explored 5% of them. And around 300 million years ago, I wasn't around then, we only had one massive supercontinent called Pangaea, with one huge sea, Panthalassa. Surprisingly, coral reefs are the biggest living structures. They consist of small coral polyps, but together they make a true community of organisms and a very important part of Earth's ecosystem. Some coral structures can even be seen from space. The Earth's surface is not evenly shaped, which means mass is uneven too. That way, gravity is not the same in all spots on Earth. There's a mysterious anomaly in the Hudson Bay of Canada. The gravity there is lower than in other regions surrounding this area, and scientists believe it's because of melted glaciers. During the last ice age, that region was covered in ice, which is now long gone and melted. But the planet hasn't completely recovered from the icy burden. Gravity over any area is proportional to its mass. The glacier left an imprint that pushed aside a part of the planet's mass, which is one of the reasons why the gravity is weaker in that area. Some bugs get nastier when in space, without gravity. Studies showed some bacteria, like Salmonella, can make worse damage in space because there's something in the lack of gravity that makes them tougher and changes their activity. The days on Earth are slowly getting longer. When the planet was formed, days were about 6 hours long and gradually got longer. 620 million years ago, a day lasted 22 hours. Today, we have 24 hours, but it's increasing by around 1.7 milliseconds every century. This happens because of the moon. It's slowing down our planet's rotation with the tides it helps create. When the Earth is spinning, tidal ocean bulges are pulled a little bit ahead of the Moon-Earth axis. That makes some sort of force that slows down the rotation of our planet, which is how our days are getting longer, but really slowly. We'll have to stick to our 24-hour schedule for a very, very long time. Earth's core certainly seems to be far away from us, but the distance is not that big, 1,800 miles. That's shorter than Route 66. The strongest earthquake we ever had was in Chile, a magnitude 9.5. If an earthquake ever reached magnitude 12, it could split our planet in half. Also, if there's an earthquake happening, it can hit more than 400 miles under the surface, which is why people on the other side of the planet can literally feel that. Our planet has around 100 million times more individual viruses than there are stars in the universe. Clouds are not some fluffy things whose shapes we sometimes like to watch. They actually help regulate the temperature of Earth. If we could pull out all water droplets in clouds and bring them to the surface, that would cover the planet with a liquid film as thick as a human hair. And yet, such a small amount of water brings enough differences with the weather and climate. Our planet would be 13 degrees hotter if it weren't for clouds.
There are thousands of satellites flying around Earth. Some are needed to provide communication and GPS. Others monitor the weather and climate changes. In 2009, one of these satellites was circling our planet and scanning the waves reflected from the Earth's surface. The satellite was looking for changes in the emission of carbon dioxide coming from the planet, but it found something else. Something that completely changed the principle of studying the Earth's ecosystem. The source of the wave was utterly unknown. Scientists wanted to know the nature of these waves, so they tuned the satellite's instruments to the desired frequency and looked at the Earth. At that moment, they saw an unknown red glow surrounding our entire planet. In some places, the glow was weak, and while in others, it shone brightly. At first, everyone assumed that it was sunlight reflected from the Earth and produced unknown red particles. However, the analysis showed the glow's source was on our planet, and it never came from the sun's atmosphere. The glow may be the result of humanity, city lights, exhaust fumes, or something else. But again, scientists made a mistake. The brightest red light was radiated from places without humans. There were no traces of modern civilization. It turned out those places were swarming with plants. The brightest waves come from the Amazon jungle, croplands of the Midwestern U.S., northern evergreen forests, and other green areas. To understand the cause of the planetary red shining, scientists began to restudy plants. Every living tree, leaf, or blade of grass absorbs carbon dioxide and produces oxygen necessary for life. Plants manage to do it thanks to their ability to absorb sunlight. This process is called photosynthesis. New research showed that every plant emits a red glow during photosynthesis. It happens because they don't absorb all the incoming sunlight. They give part of it back in the form of a red glow, and this part is only 1% from all the receiving sunlight. This small amount of red light is impossible to see with the naked eye, but if you look at millions of plants from afar, the wave can be noticed. But still, with the help of special devices, this new photosynthesis process is called chlorophyll fluorescence. This is a hugely important discovery that allows people to monitor the state of nature. Previously, changing the color of trees helped us understand that something was wrong with the forests. For example, if a tree turns yellow, then it's probably not healthy, and we could observe the plant's state through satellites. But there are many exceptions to this method. In autumn, in many regions, almost all trees turn yellow and shed their leaves. But in any case, this monitoring system is not very effective. If we see an unhealthy tree because of its yellow leaves, then it's already too late to cure it. Any change in the red glow allows determining problems with the vegetation before the leaf color changes, and this helps to do something just in time. With the help of satellites, people can now see the problem areas of the planet. Also, the glow helps understand how much carbon dioxide and oxygen trees emit. We can learn about the plant's problem even before it occurs. The glow also comes from seaweed and phytoplankton. More than 50% of the oxygen in the atmosphere comes from oceans. Theoretically, it's possible to scan other planets in search of the red glow, to understand which of them has a habitable atmosphere. The red glow doesn't only come from our planet. In the depths of outer space, through a telescope, you can see the Horsehead Nebula, one of the most beautiful places in the universe. It's located in the constellation Orion. People called it so because of the similarity with the thrown-back head of a horse. This nebula was first discovered in 1888. This huge area of space is illuminated with a rich red color. This beautiful shining is possible because there are many super powerful blue stars inside the nebula. Their energy is absorbed by one of the most common substances in the universe, hydrogen. Hydrogen atoms receive such a strong charge from super-powerful stars that they emit red light when they collide with electrons. Just imagine if a super-powerful star was burning near our solar system, or if our planet was located in the Horsehead Nebula. Perhaps we wouldn't notice the red glow, so we would live inside this glow. We can observe beautiful multicolored nebulae only from the side, being thousands of light years away from it. Let's go back to our planet. By the way, there's another amazing glow surrounding Earth. It seems to be pulsating, shimmering with different colors, constantly changing its shape. If you look at our planet through special equipment, you will see that it's located inside this pulsating, uneven bubble. The bubble layer is quite thick. It covers the planet at an altitude of 50 to 400 miles above the surface. Even the International Space Station flies inside this glow. Almost all the satellites surrounding the Earth are in the zone too. It's called the ionosphere. It ensures the operation of communication in navigation systems. It helps radio signals and GPS to get to our mobile phones. The ionosphere is a layer of charged particles that separates the upper layers of the atmosphere from pure space. In simple words, this is a sort of an edge of our planet, the boundary between the place where we can breathe and the complete vacuum. Sunlight takes 1 or 2 electrons from the gases around the Earth, so these gases become charged particles. A huge accumulation of these floating particles creates the ionosphere. It's constantly changing its shape and size, as the planet is rotating around its axis and sunlight's falling unevenly. During the day, the ionosphere is always larger than during the night. Because of this, it looks pulsating and moving in different directions. This instability shortens the life of orbiting satellites and often puts them out of action, but it also helps to provide communication. Radio signals and GPS pass through it and reflect from charged particles and fly to our phones and navigation devices. Earth is not only glowing but also pulsating. An unknown pulse is coming from the surface or the depths of the planet. The pulsation repeats every 26 seconds and never stops. At some point, it's similar to a human heart. It's working almost in the center of the chest. Earth's pulse comes from the planet's center, the equator, but the exact location of the source is unknown. In the 1960s, the pulse called microseism was discovered by seismologists in the US. More than 50 years have passed, and scientists around the world still don't know the nature of this phenomenon. It seems as if our planet has a heart hidden inside the crust. According to research, this heart may be located in the southern or equatorial part of the Atlantic Ocean in the Gulf of Guinea called the Bight of Bonny. Every winter, the pulse increases, but then its strength weakens again. Scientists began to explore this place and put forward the theory that the ocean creates the pulse. Waves cross the surface and hit the continental shelf of the planet. This impact deforms the ocean floor. A strike to any flat surface works on the same principle. Hit any plate with a hammer, and you will feel a vibration through the object. The same beats are created by waves hitting the coastline. There are waves all over the world, not only at the equator. So why does microseism occur at the equator? Because in this place, the sun heats our planet the most. Solar energies increases storms and winds, accelerates ocean currents. Also, in 1980, geologists found out that microseism pulsates powerfully during storms when the waves hit the shore stronger. Not all scientists agree with this theory. Some researchers believe the planet is pulsating because of the seismic volcanic activity, and there's one that's located on one of the islands in the Bight of Bonny. The place of pulse origin is close to this volcano, but further observations have shown that microseism can be found in all places of the Gulf of Guinea. Scientists still can't prove any of the hypotheses.
The Earth has 3 main layers: 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon, and made of nickel and solid iron. It's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which, in turn, protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds. If the Earth shrinks and loses its mass, then the forces of gravity will become weaker every day. People will manage to jump high and float in the air. There won't be enough air, since the entire atmosphere will simply fly into space. All things will become light. Water will slowly turn into gas, and the International Space Station and the Moon will fly out of Earth's orbit and go space surfing. But if the Earth began to shrink by 1 inch per second and didn't lose mass, then our entire solar system would disappear in 15 to 17 years. The number of disasters would increase exponentially, and all of it would start with a small push. You're in a supermarket shopping for food when you suddenly feel an earthquake. It's not strong, but it makes a pack of chips fall off the shelf. From this moment, Earth begins to shrink inward. Imagine a slowly deflating balloon. Its size is shrinking by the second, but its weight remains the same, which means that its density increases. The same thing is happening with our planet. Everything from the core to the Earth's crust is slowly compressing inward. Oceans, vegetation, houses, everything remains the same. On the first day, people don't notice the difference. During the day, our planet shrinks by 1.3 miles. This is 0.01% of the entire Earth. After a month, you may feel slightly unwell. Headache, weakness, increased laziness. Your body feels changes in pressure. Earth shrinks by 40 miles in a month. The weight of the planet remains unchanged, but the density increases. When you're on a decreasing object with increasing density, you feel the strengthening and weakening of gravity at the same time. It's difficult for you to move your feet, but your upper body feels light. You live near the shore, so you notice that the water level has risen. You take a handful of sand. It seems heavier than usual, but at the level of your head, the sand loses a little weight. This happens because there's an enhanced gravity working below. The higher you go, the weaker the gravity becomes. But with every second, the level of enhanced gravity rises. You can get to the top floor of a skyscraper and feel incredible lightness, but the lower you go, the stronger the pressure becomes. Hurry up! The skyscraper will soon fall. Gravity and changing Earth's shape destroy cities all over the world. The building's foundations break because of the constant shrinking of the Earth's crust. Houses become heavier and create much more noise when they fall. The dust rises high in the air and flies away to the sky. A part of the dust settles on the ground faster because of gravity. Months pass by. In the forests, trees fall as the ground compresses and breaks their trunks. The production of crops is interrupted. Corn, wheat, sunflowers, everything stops growing in such conditions. After a walk in the park, your legs feel so tired, as if you ran a marathon. When you're lying in bed, it's difficult for you to get up. It seems as if a huge magnet was pulling you down. Also, you feel a load on your eyelids. Your body constantly feels the same tension that you do in the middle of your workout at the gym. You'd sleep easily on the upper floors, but they no longer exist since all the buildings were ruined. The atmospheric pressure increases, and this causes headaches. Power plants and factories no longer work. Dams break, and water floods many cities. The internet has disappeared. No more planes are flying in the sky. All navigation tools stop working correctly because the entire landscape of the planet is changing. There are no more working electronic gadgets in the world. All cars consume more gas now as their weight goes up thanks to increased gravity. You also get a bit heavier. Your legs have to withstand a huge load. Your sneakers are torn because of the increasing pressure. Rocks and hills fall to the ground. Avalanches descend in snow-covered places. Changing the size of tectonic plates awakens volcanoes. They spit millions of tons of ash into the sky, but it quickly settles on the ground. The sand in the hourglass is flowing faster, same as the water out of a bottle. Throw a basketball in the air, and it will return to the ground faster. But you won't be able to play basketball, since the ball doesn't bounce off the floor. Now it's as heavy as a bowling ball. The sea level is rising higher and higher. The upper layers of the oceans flood many coastal cities. The water pressure on the seafloor increases several times. No living creature can survive under such conditions, so all the huge squids and other monsters swim out of the depths to the surface. At night, you look at the starry sky and notice the moon has become a little smaller. It's moving away from the planet, but not for long. Astronauts on the ISS panic. It seems to them the station has moved away from the planet. However, they are still in Earth's orbit. The planet is decreasing in size, but doesn't lose its mass. The Earth's gravitational forces remain unchanged for the ISS, but now the station is flying much faster around the planet. Water floods almost all the continents. The clouds used to be high in the sky, but now they descend lower and cover the planet's surface with a thick fog. Raindrops fall faster and hit the ground stronger. The temperature is falling all over the world. The planet is moving away from the sun and slowly freezes. But then, everything changes. The water goes back. Now the gravitational force of the planet is so strong that it returns the oceans to their places. The water pressure is increasing. It'll be much more difficult for you to swim, even near the shore. The density of Earth reaches colossal dimensions. Now if you stumble and fall, you won't be able to get up. Only small animals and insects can move as fast as before. The lighter an object is, the less gravity affects it. A year passes. The Earth has shrunk inward by 470 miles. The air, gases, the atmosphere, everything becomes so dense and heavy that it's difficult for you to breathe. You won't survive for long in such conditions. The shrinking planet is moving us away from the sun. The sky becomes gray as the light coming from the sun has decreased. The nights are getting too dark. The moon no longer lights up the night sky. A ballpoint pen lying on the table seems heavier than a barbell. The table can't handle it and breaks under such weight. 8 years have passed. The planet is reduced by almost a half. However, its weight remains the same. All the seas and oceans have frozen because of the decreasing temperature and increasing pressure. The shrinking planet exerts enormous pressure on the natural minerals hidden inside the crust. This creates ideal conditions for the appearance of diamonds. They used to be at a depth of 60 miles. Now, they get out to the surface. 10 years have passed. The Earth's diameter has decreased by 4,700 miles. Our planet is smaller than the moon, but almost 80 times heavier. All the space satellites flying over the planet have fallen to the icy Earth. The Earth is becoming one of the heaviest space objects in the universe. The force of its gravity attracts the moon. It collapses into millions of pieces and flies around our planet in the form of a stone belt. 17 years have passed. Our planet can fit on the tip of a hair, but it hasn't lost its mass. The colossal density on such a small area turns our Earth into a black hole. It's getting heavier and more massive. All the planets of the solar system are collapsing as the gravitational black giant is growing. The sunlight goes there and never comes back. The black hole absorbs not only matter, but also time. It becomes thousands of times heavier than the sun. Our star splits into millions of thin strips of light and releases the most powerful streams of energy. The black hole absorbs it. Traffic. You're stuck on a bridge waiting for the line to move, but you've been in your car for more than 2 hours. You're gonna be late to pick up your friend from the airport. Suddenly, the bridge starts shaking. Everyone gets out of their cars and runs to the other end of the bridge. But there are so many people panicking that they start pushing and shoving each other. The bolts on the bridge begin to snap one by one, making the bridge shake even more. Almost everyone has already crossed to the other side. But the first half of the bridge falls down, causing all the abandoned cars to slide to the ocean. You start climbing on them, trying to get to safe ground. Almost there, you jump over some cars and make it to safety. You make it just in time, because the whole bridge has collapsed into the ocean. Everyone's confused. You start to feel the ground inflating. Someone screams, and everyone starts to disperse like tiny ants. You run into the city center and see some buildings start to shake. The sidewalks are cracking. The fire hydrants burst open. All the glass in every building shatters. Everyone is running away from the buildings. Many cars are crashing into each other, blocking many paths for people. You see people get evacuated, so you follow them into the countryside, which has no buildings around. There are thousands of people standing side by side, scared and confused. Someone stands on a podium and announces that the Earth is expanding by 1 inch per second. Everyone is advised to go with escorted safety cars into the city to pack up their belongings and head to a new shelter. They have to be quick, or else the entire city will collapse. You enter one of these safety cars, and they take you back home. You can see the ground getting bigger and bigger. You reach downtown, where all the skyscrapers are. They're all swaying and might collapse any second. Suddenly, they all topple over each other just like dominoes. You were lucky enough to grab some of your things, but the buildings have trapped you inside. A helicopter comes out of nowhere to rescue you and everyone else. From an eagle-eye view, you can see the whole city crashing down. Every road is unrecognizable. Bridges and tunnels have completely collapsed. The helicopter takes you to the shelter, where you'll be spending the rest of your life. A group of scientists explain to you that the Earth's surface will increase by 40 miles in a month and by 500 miles in a year. That's even further than a trip from New York to Toronto. You're shocked by what you hear as the planet continues to expand. You were supposed to pick up your friend from the airport, but all the roads are destroyed now. Suddenly, you get a call from him. He landed just as the ground started expanding, and now he's stuck at the airport. You sneak off from the base, find a bike in the middle of the road and head there. It'll take you a couple of hours to get there, since the helicopter took you to the opposite end of town. You ride along the bumpy road that has changed completely. The flat open road is now full of mini hills and trenches. The farmlands are inside out, and most mills are destroyed. You finally reach a mountain pass that looks very unstable. You have no choice but to go through it. It used to be a public hiking trail, but now it looks like a landfill. You get there slowly, looking out for any signs of danger. Many trees have been uprooted and are leaning on each other. Suddenly, a huge tree tumbles down and blocks the road in front of you. You speed up and decide to use the tree as a ramp. You fly across the obstacle, making it to the other side. But as you land, you notice a massive landslide. You speed away on the bumpy road. The whole mountain starts to shake and finally collapses. You're riding through everything, dodging every tree, rock, and bush until you make it out. You turn around and see the whole mountain collapse behind you. There's no going back. You continue through the open road until you see a broken sign to the airport. It's not far away, and when you finally get there, you try calling your friend. The phone no longer works. The reception is awful, but suddenly you realize all the cell towers are probably destroyed by now. The sun begins to set. You almost give up, but you spot him in the distance. You pick your friend up and head back to safety. As you ride back, the airport runway starts to collapse. It's located right next to the ocean. So with the infrastructure collapsing, ocean water begins to find its way to land. You're at maximum speed, trying to get away with a tidal wave gaining on you. With the whole mountain collapsed, you can't go back the same way. Water begins to touch your legs. The bike can barely make it out, but you find a little passage and escape. You detour and take the longer route through the city to get back to the shelter. But the city looks even stranger than when you were there in the morning. Many rats and animals are roaming the streets. Lampposts and telephone poles are blocking the roads. Glass windows you saw a couple of hours ago are now all over the floor. It's too dark to see ahead, so you and your friend make camp in what used to be a convenience store. You make sure there's no roof above, otherwise it might cave in while you're sleeping. Many dangerous animals are lurking outside. You finally fall into a deep sleep. The next day, you ride along and the ground level gets even higher. In 24 hours, the ground rose by around 1.5 miles. You see a bunch of people walking, trying to find shelter. You tell them about the rescue team and explain to them how to get there. After a couple of hours, you finally arrive, but the place is deserted. There are no more improvised tents and buildings. All the people disappeared. You try to investigate and find out what happened, but you've got no clues. As you continue walking, you start to feel heavier than usual. Since the Earth is getting bigger and bigger, gravity is getting stronger as well. You get tired more quickly than expected, and an uphill walk seems impossible. You get back on your bike and continue driving in search of answers. In the distance, you spot a dome structure in the middle of a field. You enter and notice that everyone evacuated here. You settle in. Inside the dome, there's a construction of a giant vehicle the size of 3 malls. It'll be the new mobile city. 1 year later, the Earth's surface grew by 500 miles. Some mountains grew larger, but some are embedded in the land. Forests and jungles lost around 90% of their trees. Oceans and seas created a new map formation since so much water was trapped underneath the land. All of this made oxygen levels drop. The gravitational force became even stronger, making it much more difficult to walk without catching a breath. Climbing hills is definitely not easy. Many tsunamis, volcanoes, and earthquakes destroyed lands and cities, and they're now happening more frequently than before. The heat from the Earth's core is getting stronger. The entire world economy collapsed as soon as the Earth started to get bigger. Digging for oil is now impossible, so you can't use any vehicle that's gas-powered. The vehicles of today have specialized wheels for rough terrain and are powered by the sun. Everyone lives in those giant domes with huge wheels to constantly change location whenever it gets risky. Congratulations! You're now one of the dome drivers, and you're heading to the East Coast. The place is packed with around 5,000 people living and working inside. Everyone has specific responsibilities so that the area there can be well maintained. But wait, traffic? Another mobile dome city is in front of you, and it's barely moving. As long as everyone's in the dome, they're safe. For now.
I don't know who I'm writing this to or why. It's the end of the world after all, so everybody knows all I have to say anyway. But somehow, I feel that I have to tell this to someone. So, it began as slight jolts from under the ground. Nobody really paid attention to them, especially in seismically active regions. People thought these were just minor earthquakes. They talked about them in the news, but only few actually cared. My parents, I was only 12 back then, were among those who did, but let's save it for later. In just a year, the jolts became much stronger and more frequent. In some areas, they turned into full-fledged earthquakes, doing a lot of damage to cities and villages. Worse still, previously dormant volcanoes began waking up. All over the world, people started raising alarm. Scientists talked a lot about climate change and impact of humankind, but it was obvious nobody really had any definitive answers. It didn't get any better either. As months went by, earthquakes and volcano eruptions gradually grew in power and frequency. At first, only one major natural disaster per month was reported. But in 2 more years, there were at least 4 of them occurring within the same period in every corner of the world. Even the normally calm regions suffered from quakes and resulting tsunamis. People tried to adapt, but it was all unfolding too fast for us to react adequately. All we had left to do was to learn to be always ready to move out from our homes and run. We stopped building big and sturdy apartment buildings, opting for lightweight 3D printed houses. They were easily destroyed but easily built too, which was a huge advantage. Items of luxury were rapidly losing their value, while on the other hand, mobile electronics and survival tools grew in price. People began really appreciating what they had and each other. Neighbors were helping one another, and whole towns unified their efforts to build strong communities and prepare for the worst together. And the worst came sooner than we expected. One day, the whole planet was shaken in one titanic earthquake. We thought it was the end for us all, because the ground went on shaking for hours and didn't cease until the next day. And then came reports from the Atlantic coast. The ocean receded, leaving vast swaths of naked sand and corals. Research teams on helicopters went to learn what caused this cataclysm and found the unthinkable. There was an enormous whirlpool in the middle of the Atlantic, hundreds of times bigger than the largest sinkhole in the world. The water from the ocean was gushing down the gigantic drain, as if someone pulled the plug on the bottom. In a sense, that was exactly what happened. Tectonic plates beneath the Atlantic came apart, forming a huge gap in the bottom. Boiling magma poured out, but was extinguished by the overwhelming mass of water, which then rushed down into the abyss. It went away so quickly that the overall water level fell in a matter of hours. The event was dubbed the Great Atlantic Rift, but it was still only the beginning. With the rising frequency of earthquakes and eruptions, wind patterns around the world changed, resulting in massive hurricanes. It seemed the whole planet was against its inhabitants. But like I said earlier, my parents were the ones who cared, and they had to know the reason. They were geologists at the International Space Agency, which continued its work even through all the cataclysms. And it was them who came to the distressing conclusion. For some unknown reason, the Earth had started to grow in size. It would explain everything. The ever more frequent earthquakes were caused by tectonic plates come into motion. The flowing magma was pushed from the mantle up towards the crust and burst onto the surface in places suited exactly for that, volcanoes. And that meant there would be other events like the Great Atlantic Rift, only even more catastrophic. After another year, we moved to live in the agency, along with the families of other employees and research workers. The buildings were made to withstand almost anything, so we were protected from the horrors of the outside. We took in as many people as we could, but of course, it wasn't nearly enough. Millions more were left to their own devices, and we could only hope that everyone was safe. By that time, as scientists estimated, the planet had already grown 1.5 times its original size, and by the looks of it, the rate at which it ballooned was growing. In another year of our bunkered life, we witnessed it grow twice again. Rifts even bigger than the one in the Atlantic popped up in different parts of the world, causing widespread chaos. Everyone went to live underground where it was relatively safe. Communications between continents were all but lost, and all we learned about the situation above was from daring expeditions by scientists. The planet was ravaged by quakes, volcanic eruptions, tsunamis, and hurricanes, happening almost daily now. Life on the surface was virtually impossible. It was then that the joint team of researchers and engineers suddenly came out with the solution they'd been working on for the last 5 years. They called it the Ark. It turned out several teams agreed to build huge spaceships to evacuate humankind, along with the surviving animal, fish, and insect species in case the Earth comes apart. And the time they'd feared finally came. Everyone in the agency's buildings, including me and my parents, were escorted to an enormous hall where one of the arks was kept. All other people from the continent who managed to come were also there. We were given personal IDs and then allowed to board. Each person was allocated a separate capsule that was to keep us hibernating for the whole time of space travel. We were told we were the colonists, the pioneers in space settlement. We were going to Mars. And that's how I ended up here, where I'm writing all this. We successfully boarded the Ark and were put to sleep in our capsules. When I woke up, we were already landing. I won't bore you with the details of terraforming and settling in our new home. At first, we all wore special suits equipped with oxygen tanks. But soon enough, we built a dome with artificial atmosphere and started making the territory suitable for living, both for us and for the animals we brought. Since then, 10 years have passed already. We're feeling almost at home on the red planet, which isn't really red anymore. There are lush forests and big cities sprawling all around. Mars is inactive, so there are no earthquakes or hurricanes here. Life is pretty peaceful, although it's as busy as can be with all the work that still has to be done. But all this time, we've all been anxiously watching our home planet grow in size. At first, it was barely visible in the night sky, but as months passed, it became more and more apparent until one day it could be viewed in some detail with an unaided eye. Today, it's the size of the moon in our skies and visible even in the light of day. The sun is much smaller from here than it was seen from Earth, so basically, our home planet is now larger than its star. Through telescopes, we can see its surface covered in scars and fissures dozens of times bigger than the Grand Canyon. There are no more seas and oceans, and continents drifted far apart. The once green and blue and welcoming world is now a barren wasteland, boiling with fire and brimstone. The sun isn't helping it either. When the planet was small, the star bathed it in its light and warmth, giving it life and energy. Now, when Earth is 100 times larger, the sun is scorching its surface and burning off the remnants of its atmosphere. But even that's not all. With the size, the gravity has grown too. Being so big and massive, Earth has collided with the moon, virtually eating it up. Venus, which was similar to the previous Earth, started to be tugged toward the suddenly grown planet and was soon to run into it as well. And Earth itself is slowly gravitating toward the Sun. Scientists say that one day it would first consume both Venus and Mercury and then get burned completely in the Sun's heat. Wow. All I can hope now is to never see it with my own eyes.
You're a seismologist working at a geological observatory. In the morning, you check the equipment that monitors seismic activity and adjust the instruments. Then you inspect the movements of tectonic plates. Suddenly, one of the devices shows a strange signal. It's like a small earthquake. You make a record of this push and continue working, but the signal repeats again. A little time passes, and the devices fix it for the third time. You understand that this is not an earthquake because the signal is too weak for this. It repeats every 26 seconds and resembles a pulse. The human heart pulses close to the center of the chest. The pulse of the planet also comes from its center, the equator. You call other specialists and tell them about the unusual phenomenon, but no one knows what it is. Also, you can't determine the source of the pulse. You arrive at the place where the vibration comes from and find nothing. The ground still pulses under your feet, but it's impossible to figure out the reason. In the 1960s, the pulse called microseism was discovered by seismologists in the US. More than 50 years have passed, but scientists around the world still don't know the nature of this phenomenon. It looks as if our planet has a heart hidden inside its crust, beating every 26 seconds. According to researchers, this heart may be located in the southern or equatorial part of the Atlantic Ocean in the Gulf of Guinea. This area is called the Bight of Bonny. Every winter, the pulse becomes stronger. Then it weakens again by the summer. When scientists began exploring this place, they put forward a theory that the ocean could create the pulse. Waves hit the continental shelf of the planet. That impact deforms the ocean floor. A human hand hitting a table works on the same principle. Sit on one side of the table and put your hands on it. Let someone else hit the table from the opposite side. You will feel a vibration. Ocean waves hitting the coastline create a similar effect. Someone may object that there are waves all over the world, not only at the equator. Yes, but that's where the sun heats our planet the most. Solar energy causes powerful storms and winds and accelerates ocean currents and waves. Also, in 1980, geologists found out that Earth's tremors became stronger during storms. In other words, when waves hit the shore with more power. Not all scientists agreed with this theory. Some researchers believed the planet was pulsating because of the seismic activity. It was coming from a volcano located on one of the islands in the Bight of Bonny. The place where the pulse was the strongest is close to the volcano. But further observations showed that the Earth's tremors happened in all parts of the Gulf of Guinea. That's why scientists can't prove any of these theories. Our planet pulsates not only from within. Earth is surrounded by a thin luminous halo. It's constantly changing its shape and shimmering with different colors. If you look at our planet using special equipment, you'll see that Earth is inside an uneven pulsating bubble. It's located at an altitude of 50 to 400 miles above Earth's surface. This bubble is called the ionosphere. That's a layer of charged particles that separates the upper atmosphere from space. In other words, this is the boundary that sets apart the region where you can still breathe and a complete vacuum of space. The International Space Station travels inside the ionosphere. Most of our satellites also move within the borders of the pulsating bubble. This natural phenomenon can both help and disrupt the operations of communication and navigation systems. It helps radio and GPS signals to get to our mobile phones, but it can also interrupt the stable connection. It all depends on the number and density of charged particles. Sunlight takes away 1 or 2 electrons from the gases surrounding our planet, and they become charged particles. These particles make up the ionosphere. It's constantly changing its shape and size. It happens because the planet rotates around its axis, and the sunlight falls on it unevenly. During the day, the ionosphere is always larger than at night. Because of this pattern, it's pulsating and constantly moving. This instability shortens the life of orbiting satellites and often puts them out of work. Radio and GPS signals pass through the ionosphere and get reflected from charged particles. Then, they fly further to their destination, to phones, navigators, and other devices with GPS and radio receivers. Our planet is not only pulsating, but also buzzing. The noise that Earth produces is called the hum. It's impossible to record this sound, but even so, 2 to 4% of people on the planet hear it. All over the world, people who aren't connected in any way speak about a weird buzzing sound. It interrupts their sleep and doesn't let them concentrate. This noise follows them everywhere. Perhaps you also hear it but don't pay attention. But once you notice the hum, You won't be able to unhear it. Some residents of a small village in Scotland describe this humming as a thick, low-frequency sound. There's a website on the internet with a map where people all over the world register and describe this mysterious noise. Almost everywhere, it's a low-frequency vibration, barely perceptible to the human ear. Sometimes, people say it resembles the noise of an airplane flying overhead, but quieter. Some people describe it as the sound of a running truck engine placed in the backyard. It's humming in the street when they come home. And it gets louder when they are lying in bed. If you hear it too, you can mark it on the map. There are records dating back to the 19th century that describe a sound similar to the hum. But for the first time, the media started talking about this phenomenon in the 1970s in England. Since then, many theories have been made by scientists and people who try to catch the hum. There is a hypothesis that claims the noise comes from high-speed traffic on highways, or it might be caused by too many airplanes flying in the sky. The hum and vibrations can be produced by electric stations, factories, industrial equipment, and huge air vents. Some people believe the reason for the hum is the movements of tectonic plates and the Earth's crust under the ocean waters. But no one has managed to prove it yet. In most cases, people hear the hum in big cities, and, of course, they often complain about this and demand to conduct investigations. But all the attempts to find the source of this noise haven't given any results. It's possible that 4% of people have a unique hearing that catches low-frequency sound waves. One theory says the source of the hum is special radio signals. They're used around the world to communicate with submarines. These radio signals can make people have a response. It feels as if you hear some buzzing. This happens when radiant energy collides with the soft tissues of the human skull. It stimulates the auditory nerve and creates an auditory hallucination. But the coolest theory appeared in the city of Sausalito in California. A lot of people there hear the hum, and biologists believe that fish might be the reason. There are many toadfish on the west coast. They can produce a unique sound that is not audible itself, but the sound wave coming from the fish resonates with the buildings located near the coast. This resonance produces the hum. Even one fish can do this. Imagine what happens when thousands of these sea creatures scream at the same time. But not only people living near the shore have problems with the noise. Those who live in the city center hear the hum too. And since the sound waves created by the fish can't spread so far, the theory was quickly refuted. Our planet isn't the only humming one. In 2020, scientists recorded a strange buzzing sound on Mars. This is a quiet, long beeping that spreads across the red planet's surface. Sometimes it changes a bit because of Marsquakes, which are another mystery. Earthquakes occur on our planet because of the tectonic plates' movements. Stress accumulates and gets released in the crust. This produces earthquakes. But there's no plate tectonics on Mars, so Marsquakes aren't supposed to be happening there.
You're on a plane heading to an important astronomy convention when you see a large figure outside your window that eclipses the whole sun. You spit out all of your coffee, and everyone in the plane stares outside in shock. You then notice that it has rings like Saturn. You were supposed to fly to Japan, but you're forced to land in California. As soon as you land, you look up in the sky and see some more giant planet-like structures floating around in the sky. Everyone is taking pictures and trying to figure out what's going on. Suddenly, you notice a huge ball of fire crashing down near the airport. Everyone scrambles for safety, and luckily, it ends up in the middle of the runway with no one around. The bad news is, there's no more runway for planes to land. Everyone huddles together for safety, and more large objects appear in the sky. All communications have ceased or broken down since these large objects have ruined all the satellites. Some scientists nearby mention that these objects are the planets of the solar system going within the same proximity as our moon. Mercury and Venus look like moons, but Saturn is occupying a lot of sky real estate. You tell those scientists that you're an astronomer. They invite you to join them on a trip to Antarctica, to the observatory station in the South Pole. They need every mind to help solve this mystery. You get on a ship with the coordinates set to Antarctica. The waves are extremely rough for typical daylight and non-stormy weather. You finally make it to the shore of the continent after a few days and have to get in a snowmobile all the way to Amundsen Scott's South Pole Station. Over here, you and a group of scientists will figure out what's going on. You weren't prepared for the freezing temperatures, even though it's July. You arrive at the station and see all your fellow scientists running around with paperwork and blurting out stuff about planets orbiting our atmosphere. You arrive at the conference room where the lead scientist explains what's going on. One by one, the planets are coming closer to us until they're aligned with the moon, but they still don't know why and how. Venus arrived first, and now Saturn is getting closer. The moon is around 240,000 miles away from Earth, and it affects the tides of the oceans and seas with its gravitational pull. Since water is less dense than land, we can see the tides change. So high tides occur when the Earth is pulled towards the moon. And since the other planets are coming closer to Earth, the gravitational pull is erratically changing. In a couple of hours, Saturn will be in the same distance as our moon. You head to the large telescope and observe the planets. Any plane or helicopter won't fly properly and won't have the proper radar technology to help it. You keep observing and notice Mars getting closer to Earth. You get news that tidal waves are rising very often now, and some island nations are even being washed away. Good thing they got evacuated beforehand. With Mars closing in, you notice Neptune also getting closer. You can feel the gravity on Earth fluctuate with every step you take. You report your findings to the lead scientist, and the only way for survival is to quickly build bunkers far away from oceans and seas that can host many people before the other planets close in. A team of engineers arrive and start building. Wave after wave of survivors come and settle into the bunkers, practically built overnight. With every hour, more planets are getting closer. Mars and Neptune have already settled in, with Mercury, Venus, and Saturn. Pluto and Uranus are now visible to the unaided eye and are making their way towards Earth. The gravitational pull is getting completely out of hand. The snow in the Antarctic desert remains floating for several seconds whenever someone walks on it. You can jump a lot higher. It's now nighttime, but the sky isn't dark as usual. The planets are reflecting a lot more sunlight than our moon. It's barely visible now. With more observations, you notice comets and meteorites flying very close to our atmosphere. Some are even crashing down on Mars and Neptune. Everyone can see it from Earth. Other space debris also finds its way into Earth's atmosphere. But you notice something strange. The planets are now orbiting Saturn. You check your calculations and find out that the planet's positions are now aligned with Saturn's orbit. That's because it has the biggest mass among all the planets. Saturn's rings are made up of ice particles, some as large as a bus and others as tiny as pebbles, but they're all crashing and interfering with the other planets. No one can feel the orbit shift at first, but later you can start to feel it. With this happening, earthquakes and volcanoes are bound to happen. This is why everyone, including yourself, is packing up and ready to flee. Antarctica has dozens of volcanoes hidden beneath the frozen ice. Some are underground, while some are right on top. Saturn's gravitational pull is much stronger than Earth's gravitational pull on the moon. This will cause the inner core to react a lot more and kickstart those earthquakes and volcano eruptions. Everyone packs up super quick and heads to the choppers to fly to South Africa. These choppers were designed to have a direct course without the need for radars to guide them. You arrive in South Africa, which is mainly covered in water. The chopper takes you closer to the center, and then you travel to the Sahara Desert. The plain surface with nothing around it will be the best option for safety. But you look up in the sky and see another planet closing in. It's Jupiter, the biggest planet in our solar system. If Earth were the size of a grape, then Jupiter would be the size of a basketball. It's approaching quickly. Many of the other planets automatically make way for it, including Saturn. You're on the road heading to the Sahara, even though it'll take days to reach by car. The sky is dark during the day, since most planets are blocking the sun. You finally make it to the Sahara Desert with other scientists, and to your surprise, a whole city was erected in just a month when the planets started showing up. You settle in your dorm, but still have a lot of work to do. A couple of days later, Jupiter breaches the atmosphere and completely eclipses us. But Earth is now rotating around it, and it's much quicker than orbiting the Sun, since Jupiter is smaller. But since Saturn is also big, Earth keeps getting tossed from orbit to orbit, like two people playing a ball game with each other. So with that happening, people on Earth are experiencing different gravitational pulls from time to time. The tidal waves keep getting stronger, and volcanoes are erupting everywhere. Since the Earth's core is getting hotter, the temperature on Earth is also changing. And with a lack of sunlight most of the time, much of the plant life is having a hard time trying to keep up. Crops are harder to plant with natural sunlight, so people are turning to artificial lighting and greenhouses. Air and space travel are impossible. The International Space Station is completely ruined, along with the satellites orbiting space. That's why cell phones and the internet can't work. Gravity is even more dysfunctional than ever. 6 months later, humanity has found some way of coping with the new normal, but things are constantly being updated. The number of hours in a day has changed, as well as days that compose a week. This used to be measured with the moon phases. A month used to be the moon achieving all phases from none to full moon, and so on. But Earth's moon has disappeared with the cluttered, disorganized planets.
Traveling back in time now, this used to be hard. We fly past the Middle Ages, the first human civilization, the ancient ancestors of the first humans, the dinosaurs, the first land animals, the ancient sea creatures, and so on to the very beginning of all time. And there it is. This nebula is our solar system. Right now, it's just a cloud of multicolored dust made of hydrogen and helium spinning around. This cloud has begun to shrink and become denser. There's a theory that there were supernova explosions near our nebula. Their shock waves squeezed the nebula from different sides until the center of the cloud became too heavy. The enormous weight presses it, and nuclear chain reactions begin at the very center of this cloud. It heats the cloud and makes it glow. Soon it forms into a dense sphere, and that's how our sun is born. It happened about 4.5 billion years ago. Our planet doesn't exist yet. There's only a disk of dust and space debris orbiting the young sun. These pieces of debris are fusing gradually and getting heavier and heavier. Let's look at the very center of this pile of asteroids. The total weight of the debris compresses the central region so much that a dense metallic core is forming there. The enormous pressure heats the core, and the temperature at the center of the young Earth reaches nearly 10,800 degrees. And there's a liquid core around the solid one. It creates the magnetic field of our planet. Now, when radiation from the sun and the solar wind reaches Earth, it smashes into a shield in the form of our magnetic field. So far, our planet is burning and looks more like a ball of lava. But it begins to cool down, forming a solid crust. At this point, another protoplanet appears on the horizon. It looks more like an asteroid, the size of Mars, and this massive piece of debris flies towards us. It hits the young Earth at such an angle that it knocks a part of our planet outward. The debris itself breaks into several pieces and stops in our orbit. After a while, all of this debris comes together to form the Moon. As a result of this collision, the Earth began rotating too fast. A day now lasts about 5 hours instead of the usual 24. But the Moon is heavy enough to slow our planet's rotation with gravity. Now, the Earth doesn't look like a hospitable place. The gravitational forces of the Moon are penetrating deep into the Earth and causing more volcanic activity. Also, meteorites are constantly falling here, causing frequent explosions on the surface. Ow! The gas that comes out of the volcanoes forms our atmosphere. The ice that was brought to our planet on meteorites evaporates. The vapor rises and turns into rain. This rainwater falls to the surface, cooling the hot lava and forming the first lakes and rivers. For several 100 million more years, Earth resembles the surface of Venus. It's a lifeless place with a bunch of volcanoes, acid rains, and no oxygen to breathe. The sun wasn't as bright as it is now. Plus, the sun's rays could barely pass through tons of volcanic dust in the atmosphere. But about 3.5 billion years ago, the first life appears here in the form of single-celled organisms that didn't need oxygen. They appeared in the shallow, warm parts of the ocean near the shore. These bacteria reigned on Earth for nearly 2 billion years throughout the Archean eon. They left stromatolites. These are stone pillars at the bottom of shallow, warm water. They're the product of simple organisms and bacteria. These bacteria evolved until they learned photosynthesis. Bacteria began to produce oxygen by absorbing the energy of sunlight. At first, this oxygen was spent on oxidizing rocks, but then excess oxygen began to fill the atmosphere. Plus, at this time, the first algae appeared, which also produced oxygen. This event is called the Great Oxidation Event, good name, which caused almost all living organisms to disappear from the face of the Earth. For simple organisms, oxygen was toxic, and the remains of bacteria and microorganisms sank to the bottom of the ocean. Many millions of years later, these remains will be recycled, and under the tremendous pressure of water and the Earth's crust, they will turn into oil. The Archean Eon ended with this catastrophe about 2.5 billion years ago. At the same time, continents were forming on Earth, which would later drift through the world's oceans like puzzles and form a supercontinent. But for now, methane and carbon dioxide still make up most of the atmosphere. They cause the greenhouse effect and the rising temperatures on Earth. But the emergence of oxygen stops the greenhouse effect, and the temperature on our planet drops. An ice age, the so-called Huronian glaciation, which lasted from 2.4 to 2.1 billion years ago, begins. Scientists speculate that our planet was almost completely covered in ice at that time, even on the hot equator. A huge change when you consider that 2 billion years ago, our planet was like a ball and lava, but now it's like a block of ice. Earth, during the Huronian glaciation, was more like Jupiter's satellite Europa. There, too, is a thick crust of ice, under which there's a liquid ocean heated by the core. The evolution of the Sun saved our planet. Since its birth 4.5 billion years ago, it's been getting bigger and hotter. So, after 300 million years of an ice age, the Earth began to warm up. But almost all life there had been wiped out, and evolution has to start all over again. About 1 billion years ago, all of the continents of our planet were assembled into one hypothesized supercontinent, Rodinia, and all the oceans made up one colossal ocean of Miravia. 750 million years ago, that continent broke apart and huge chunks of land began drifting across the planet. Complex plants and multicellular organisms appeared just at this time. Algae, sponges, and fungi weren't the only inhabitants of the ocean. This is Sprigina. They're a kind of worms the size of a human finger. We have remains of these animals that are at least about 550 million years old. 541 million years ago, the Phanerozoic Eon began. The main event at that time is the Cambrian explosion. Life began to blossom on Earth, and a great variety of living organisms appeared. Mollusks and echinoderms like starfish and sea urchins appeared. Living organisms evolved, having not only an internal but also an external skeleton, like trilobites. Some of these things could reach nearly 3 feet in length. Their protective shells suggest that there were predators in the ocean. A food chain started forming at that time. At the same moment, the drifting continents fused again. This supercontinent has a different shape and is called Pannotia. Later, these continents drifted apart again and began to collide with each other. This led to the formation of mountain ranges. Then the continents met for the last time and formed the giant supercontinent Pangaea about 335 million years ago. Here we can already see the outline of the modern continents of Africa, North and South America, Australia, and Eurasia. One of the largest sea creatures ever, the Dunkleosaurus, appeared. Some individuals could be as long as a school bus and weigh as much as a large SUV. The land had a hot and humid climate. It encouraged ferns and other plants to grow faster. Some of them could reach the height of a 3-story building. And for the first time in Earth's history, some animals leave the ocean and go on lands, such as L. generpeton and Ichthyostega. Anyway, at first, they live only on the coast because their skin wasn't adapted to the constant sunlight. In addition, they experience breathing problems. The first animals on land had both gills and lungs, but the lungs were underdeveloped, so they had to return to the water. Millions of years later, these animals evolved into more advanced amphibians. Though they were no bigger than ordinary lizards, they could already live fully on land. But this blossoming of life ended in a new ice age. Glaciers from the poles slowly crept toward the equator. Animals weren't prepared for this, and most of them didn't survive this extinction event. But 290 million years ago, evolution retook hold and more evolved land animals began to appear. Gradually, they increased in size, multiplied, and gave birth to a new species like Scutosaurus and Gorgonopsis. But this period didn't last long either. Only 40 million years later, as a result of unknown events, 95% of all living organisms on Earth ceased to exist. It could have been caused by a giant meteorite or by increased volcanic activity. Also, one hypothesis says it could have been the release of methane from the bottom of the ocean. The Mesozoic era began after this extinction. This is where the dinosaurs, as we know them, appeared and started a new page in Earth's history.
"12 a.m. Young molten Earth collides with another planet called Theia. The moon is formed. From 12 to 4:30 a.m., the planet and atmosphere are morphing. The continents merge to form supercontinents. They break up again. This happens every 400 million years. That's every 2 hours on the clock. At 5:30 a.m., we see the first single-celled organisms starting their life in the ocean. It's 8 a.m. when the first viruses emerge. By 11 a.m., photosynthesizing bacteria have managed to take in enough sun to fill the atmosphere with oxygen. It takes 1 billion years. That's 6 hours on the clock. At 11:35, we have the first snowball Earth. Even the oceans turn to ice. Don't worry, everything will melt by noon. At 1 p.m., we have special cells with internal organs coming to life. 3 hours later, they'll start to divide into 3 groups that will eventually become fungi, like mushrooms. Let's fast forward while these cells go from simple to complex life forms. At 7:20 p.m., something familiar appears: sponges. It's 7:55, and the Earth freezes over again. It melts in 2 minutes. 8 p.m., and look in the ocean. We have the first comb jellies appearing. At around 8:30, the Earth's ozone layer appears. In just 2 minutes, the ocean is filling with plants. By 8:45, life is flourishing in the sea. We now have jellyfish swimming around corals. Starfish are on their way. At 8:52, we can see trails on the ocean floor. Creatures have begun to crawl. It's 9:10 p.m. The sea creatures decide to explore the land. 30 seconds later, different animals and plants emerge. They spread all over the planet in an instant. 9:41. It's time for the first insects. They feed on newly formed plants and trees on land. By 9:45, we have the first 4-legged animals appearing in shallow waters. At 10:10 p.m., those 4-legged creatures are splitting into groups that will later become mammals, reptiles, birds, and dinosaurs. By 10:30, everything vanishes. Mass extinction takes place. Either a huge asteroid or an enormous volcanic eruption causes it. Only 5% of the species survive. 10:34, and the dinosaurs are finally making an appearance. The first one was the Nyasasaurus, but experts aren't sure if it was the real deal or a relative turning into a dino. 1045 marks another mass extinction. The early dinosaurs survive it and take the opportunity to spread all around the world. In 5 minutes, the Tyrannosaurus will appear. By 11 p.m., we have the first birds appearing in Europe. It's 11:15, and mammals are splitting into their groups. They'll branch out, forming whales, elephants, armadillos, and primates. By 11:17, dinosaurs are reaching their full size. The biggest one ever is the Argentinosaurus. It's the length of 10 school buses and tall enough to peek into a 7th-floor window. It's 11:26 when a giant asteroid smashes into the Earth. Dust flies everywhere. A few seconds later, everything clears up, but the dinosaurs have already disappeared. With the dinosaurs gone, the few mammals left can take over the planet. At 11:30, the primates separate into 2 groups, and one of those will become apes, gorillas, and, sometime later, humans. It's 11:58 p.m. The chimpanzees and bonobos appear. 15 seconds later, the hominin species begins to walk on 2 legs. It's 11:59 and 23 seconds, the time when humans appear in Africa. A second later, they've migrated all over the world. they don't have a language, and they can't use or create tools. That happens at 11:59 and 58 seconds. 2 seconds before the day ends, 100,000 years ago, our complex human species appears. You take off from Earth and park your spacecraft somewhere near the Moon. You're now almost 240,000 miles away from your home planet. That's almost 100 widths of the United States. Now you take out a giant hammer and an enormous chisel using the robotic arms of your spaceship. You place the chisel at the Earth's North Pole and strike its head with the hammer. Earth splits open like an eggshell, and you see it, another planet. It's Theia, and it's hiding inside our planet like a yolk in an egg. You'd need to go back in time 4.5 billion years to find out how it got there. This beautiful nebula will soon become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Soon, this jigsaw puzzle of debris becomes too heavy and dense. The temperature inside the giant is rising. Soon, it gets so high that it triggers a nuclear chain reaction. Another second, and bam! There's an explosion so powerful that the shock waves travel far into dark space. And the blinding flash from this blast can be seen from the other side of the Milky Way galaxy. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. You're interested in a small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core, while the oceans of lava are gradually cooling down. But a few tens of million years after the Sun's birth, you notice a strange object hurtling toward Earth. It's Theia. This small planet was born at about the same time as Earth, and now it's following a crazy spiral trajectory at enormous speed. Scientists believe Theia was kind of a ball Jupiter and Venus played with. Venus was pulling Theia in one direction, then Big Brother Jupiter pulled it back. But the Sun makes up 99.8% of the mass of the entire solar system. That's why the star sets its own rules. It makes Theia move in almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Theia is the size of Mars and as wide as the Atlantic Ocean from New York to Portugal. A collision can't be avoided. Theia is traveling toward Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If the smaller planet crashes into Earth at a particular angle, Earth will most likely be torn apart, as well as Theia itself. The collision will cause a huge blast, visible on other planets even on a bright day. Nothing will be left but some burning dust and debris. Even if Theia touches Earth only lightly, it'll still knock out a chunk of our planet the size of Australia. But the collision with Theia happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shock wave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site. Soon, it gets filled with boiling lava. The remnants of Theia and the ejected fragments of Earth begin to orbit our planet. According to one version, these fragments form two moons. At first, they travel together, but one day, they get too close to each other and collide, forming one large space body. The other theory claims that all the shards start being pulled by the remnants of Theia. Sometime later, they form the moon as we now know it. At that point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Theia that we have different seasons and 24 hours in a day. Earth has lithospheric plates. These are enormous solid pieces that make up the crust of our planet. After the collision with Theia, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet. So, Earth gets some kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over nearly 4 billion years, simple single-celled organisms have been evolving into the life you see today. According to scientists, such a collision is a very rare event. The probability that somewhere out there, there's a planet like ours that has survived the same catastrophe is extremely small. This may be the reason why we are yet to find traces of other civilizations out there in space. Meanwhile, the remains of Theia are still here on Earth. Of course, it doesn't look like an entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of entire continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Theia. They didn't mix with Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise those lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Theia might be on the moon. The Apollo space missions brought back many soil samples for analysis. Scientists have concluded that the moon is very similar to Earth in structure. People could drill deep down and take samples there. Then they'd analyze the blobs from Earth. If their structure matched, it'd be 100% proof that Theia did hit Earth 4.5 billion years ago. And that's how we got the moon. But for the time being, Theia remains somewhat mysterious. Scientists are still not sure that the planet actually existed. The whole idea perfectly fits the model of the moon's creation. But in fact, this incredible collision may have never happened.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
Now you travel 41 light years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. You take out your giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than that of Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon. Its structure changes. First, it turns into graphite. Some more pressure, and graphite turns into diamond. On Earth, diamonds form at depths below 60 miles, where the pressure is 50,000 times greater than on the surface. The temperatures there rise over 1,000 degrees, which is as hot as fire. Diamonds are ejected closer to the surface in volcanic eruptions. Still, people have to dig mines 1,500 feet deep to find these beautiful gems. The Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now imagine a diamond the size of an entire planet. You decide to fly back to the solar system. Your destination is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% the mass of Earth. Its surface is enclosed in an icy crust. It's about 19 miles thick. But what if you crack this crust with your giant hammer? Wow, Europa is completely covered in water. It's freezing here, 3 times colder than at the North Pole on Earth. The water turns into ice almost instantly, but the ocean beneath the surface is still liquid. Europa interacts with Jupiter gravitationally, just like the moon with Earth. This creates tidal forces and heats Europa's core. The core melts the ice around it. The result is a huge ocean, 2 to 3 times larger than all of Earth's oceans combined. Scientists believe that water is the basis of life. It may mean that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans. The water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria may live there. Europa is almost the same age as Earth. This means there has been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They may be building big cities and dreaming of conquering space right now. But the only thing people can do at the moment is send a probe to Europa and find out if life is possible there. As soon as the Earth is cut in half, almost all living creatures will come to an end. An apocalypse will begin, which has not been shown in movies. The atmosphere is damaged, the magnetic field will change, and the planet's landscape completely alters. But the planet will be completely renewed. and life, like a phoenix, will be reborn from the ashes. A super powerful laser would be needed to separate the planet. Such a laser has to receive energy directly from the sun. The weapon goes into space on a rocket, thousands of miles above our world. Then, once the laser arrives at its destination, it opens wide to expose plates of solar panels. The laser absorbs and concentrates the sun's rays. Then a powerful energy beam with the diameter of several cities shoots into the middle of the planet. Oceans through which the beam passes boil and evaporate from the high temperature. These vapors turn into a vast thundercloud in the sky. A strong wind drives these clouds over the continents. Heavy rain falls, which floods not only cities, but entire countries. As the tectonic plates shift, tsunamis are created. Huge waves crash onto the shore. The Earth is split in two. And this is just the beginning. The structure of the Earth, or rather, each half of it, is changing. Strong earthquakes occur all over the world. The worst disasters happen near the fault line. Billions of tons of ground are smashed. Massive landslides drag entire cities below. Chunks of land, thousands of miles in size, shoot away from our planet. All living creatures on these pieces of land fly into outer space. Other broken pieces of the planet land on the half that is closest to them. Imagine a huge rock the size of a whole city falling from the sky, and there will be hundreds or thousands of such stones. Those who live far from the cut site have a chance to survive. But even there, earthquakes will destroy houses. The moon will also start to throw off pieces from itself. These pieces, like a meteor shower, will fall onto the Earth halves and create massive explosions. These explosions will create fires. The skies will be covered with ash, and until it settles, we won't be able to see the sun. Both parts of the planet are drifting away from each other. The red-hot heart of our Earth is right in the center between the two. This is the Earth's core, consisting of molten metals. Each half of the core exudes energy comparable to a star. Between the two parts of the planet, a layer of such hot space is created that nothing can survive there. Any item that falls into this space immediately turns into ashes. The mass of the core is much larger than the ground mass, so there's a higher level of gravity. The core sucks in everything that comes close. You can't travel from one part of the Earth to the other. The core's gravity attracts any shuttle. Each half of the Earth now lives on its own. Typically, the core inside our planet rotates and creates the Earth's magnetic field. This field is a shield that protects us from the sun and space. If the shield is damaged, solar and cosmic radiation passes through the atmosphere. Because the core is divided into two parts, the Earth's magnetic field becomes unstable. Power outages begin in both parts of the planet. Microwaves, TVs, kettles, traffic lights, computers, everything is broken. The screen of your laptop or phone starts turning on and off. The video may freeze and the battery runs out and charges in 1 second. Satellites stop working, which means there will be no more GPS. High-frequency radio waves used for communication stop working, which means you can't make calls and send texts. In fact, all power plants may sink underground or be flooded because of the earthquakes, so there might not be electricity at all. Some people are sensitive to solar storms and experience severe headaches. When the magnetic field is damaged, the surviving people and animals will suffer from severe migraines. Scientists will have to invent special helmets to protect people from the sun. For full protection, people will have to live in underground cities. Compass needles no longer point north. They just spin in different directions. The birds go mad. They don't know where to fly to wait out the winter because the south no longer exists for them. All animals stop migrating. In the sky, planes can't navigate. Plants and flowers can't grow naturally thanks to the increased radiation from the sun. Livestock are poorly fed. The quality of products deteriorates. There's famine. the main goal for people on each half of the planet is survival. In some places, closer to the fault, the Earth's atmosphere is completely damaged. The conditions there will be similar to those in space. There is no air or heat. Only in a spacesuit can you stay in this territory. Unfortunately, you won't be able to jump and fly because gravity still works. Besides, it's gravity that becomes the salvation of our planet. Both parts of the Earth won't fly away from each other because of the force of gravity. Instead, they will rotate and start to attract each other. In 100,000 years, both parts of the planet will reconnect once more, and the Earth will be completely renewed. Since the core is molten metal, it will return to a single heart, but it will take much longer to connect the solid rock of the halves. A scar forms along the entire fault. The scar will be overgrown with forests and flooded with oceans, but there will be strong earthquakes in some places near this scar. By this time, all living things have probably disappeared. On our planet, conditions are about the same as 4.5 billion years ago. Seas and oceans boil, lightning strikes everywhere, tectonic plates change their shape, and lava flows from volcanoes in a rapid stream. The Earth looks like a vast boiling pot, inside which life is gradually created. Because the Earth has decreased in size and the core hasn't changed much, the gravity will be different. On land, it will be more difficult for an ordinary person to walk. They will weigh much more. In such conditions, new, previously unknown life will be created. Today, the world's atmosphere and oceans are polluted, the population is increasing, and glaciers are melting. In the future, things could be much worse for our planet. In 1,000 years, when humanity has mastered space travel, we may decide to change our residence. We'll start looking for other Earth-like planets, and maybe we'll find something. However, nothing compares to our first home, and humanity decides to cure it. Perhaps we'll come up with the idea to divide the planet in half and live on one side. And after 100,000 years, we can come back to a new healthy home. What if you divide other planets? Since they don't have a magnetic field, they won't be as affected. For example, Venus and Mars have no seas, oceans, or lakes. Some scientists think they're entirely dried up because the magnetic field has disappeared there. This led to the complete destruction of the atmospheres of these planets. The solar wind blew across their surface with such force that it dried up all the liquid. The Earth's atmosphere reflects this wind, so thankfully, we're safe. There would be no significant cataclysms on other planets, except for earthquakes. Like Earth, the two parts of each world would simply rotate until they reconnect once more.
So we don't have all the details about how the universe, our solar system, and its planets came to be. But one thing's for sure, Earth didn't just pop out of thin air. Scientists have recently made an intriguing discovery that suggests our planet may have formed way faster than we previously thought. You see, up until now, experts believe it took over 100 million years for Earth to take shape. The common belief was that lucky collisions with water-rich asteroids brought water to our planet. A recent study, however, proposes a whole new perspective. According to these researchers, there's evidence that Earth formed through the rapid accumulation of tiny pebbles, each roughly the size of your fingernail. In this scenario, our awesome planet emerged in only a few million years. And here's the mind-blowing part. They suggest that water being here isn't just some happy accident, but a natural result of the formation process. Now, this discovery has implications that go beyond Earth itself. If our planet formed quickly and water was an integral part of the process, it means the chances of finding habitable planets in other solar systems are way higher than we ever imagined. If we stumble upon other planetary systems with planets orbiting sun-like stars at the right distance, there's a good chance we'll find water there too. That's some nice intergalactic real estate that we might just be able to relocate to, should we ever get in trouble here on Earth. The old-school view was that planets slowly took shape through countless collisions over millions of years. According to that theory, water on Earth would have been a random stroke of luck, maybe caused by comets packed with water crashing into the planet during its later stages of formation. The new study introduces an alternative theory too. Picture this: a young sun surrounded by a disk where the planets are popping up. This disk is filled with tiny dust particles. Now here's where it gets exciting. Once a planet reaches a certain size, it acts like a cosmic vacuum cleaner, swiftly hoovering up all the dust in its path. In just a few million years, this tiny planet grows into the size of Earth. This not only shapes our incredible planet, but guarantees water's existence too. As the planet gobbles up the dust, it also snags icy particles floating around in the disk. So, if we use Earth as an example, it suggests that whenever a similar planet forms, it's bound to have water naturally. There's no way for us to travel back in time and see for ourselves, so there are more theories about how planets are born. Let's dive into a different scenario called the core accretion theory. Picture a big cloud of dust twirling around in space. That's where the action begins. Over time, this cloud starts pulling in an astounding 99.8% of all the matter, eventually creating our sun right at the center of our solar system. Soon enough, solar winds join the party, bringing in lighter atoms like hydrogen and helium that are closer to the sun. But those heavier elements? The sun can't pull them in because, well, they're too heavy. So what do? They gather together and stick to each other, forming their own little planets. That's how Earth, Mars, Venus, and the gang got together to create round spheres. The heavyweights, like zinc and iron, sank to the middle, forming the core, while the lighter elements meshed on top, creating the crust. But wait, we can't forget about Jupiter. Its gravitational force and the sun's were locked in an epic tug-of-war, perfectly balancing each other out. That's why we have that fascinating asteroid belt hanging out between Mars and Jupiter. Those poor asteroids never got the chance to become fully fledged planets on their own. This explains why the planets in our solar system are arranged the way they are. The inner ones, known as the terrestrial planets, like Mercury, Venus, Earth, and Mars, are closest to the Sun. They're made of denser stuff like iron, silicon, and aluminum. On the flip side, the gaseous giants, like Jupiter, Saturn, Uranus, and Neptune, are chilling on the outer edges of the solar system. These big celestial bodies are composed of lighter materials, such as hydrogen, helium, and methane. Now, let's take a trip to the outermost layer of our solar system, where the Kuiper Belt and the Oort cloud reside. These distant areas are home to ice bodies, space debris, and comets. While there may be plenty of them, they're relatively small and don't contribute much to the total volume of our solar system. The quest to understand planet formation doesn't end here. There's another mind-boggling mystery that's causing a stir among scientists: the existence of a celestial body dubbed the planet that shouldn't exist. Let's rewind a bit. Astronomers have been on a roll with exoplanet discoveries, and we've already spotted over 4,000 of them. Most of these exoplanets resemble the gas giants in our own solar system, like Jupiter and Saturn. Do you know why? It's because those massive exoplanets close to their stars are the easiest to detect. But here's the twist. A new study suggests that there's a whole bunch of Jupiter-like exoplanets just waiting to be found, and they're probably hanging out nearby. This impossible planet goes by the impossible name JG3512b, and it's remarkably similar to Jupiter, only orbiting a tiny red dwarf star. This discovery shook things up because it defied the most popular theory of planet formation. According to the prevailing ideas, it should have been impossible for such a giant planet to form around such a small star. So, what's the deal with this impossible exoplanet? Well, it turns out that core accretion, the theory we discussed earlier, can't explain its existence. According to this theory, the mass of the debris disk surrounding a young star should be directly proportional to the star's mass. But here we have a star much smaller than our Sun hosting a planet that should be way too massive for it. Something doesn't add up. Either the original debris disk was insanely enormous compared to the star, or core accretion didn't play out as expected in this particular planetary system. We've established that when talking about the Earth's formation, there's still much we don't know. But hey, we've come a long way. Back in the 18th century, a philosopher named Immanuel Kant had his own intriguing theory about planets popping up in the universe. He based his ideas on Newton's law of gravity, but added his own little twist. Kant believed that the universe started with an original substance made up of super cold, solid particles just chilling out. Then, thanks to gravity, these particles began colliding and heating up. And you know what happens when things collide, right? They get hot. According to Kant, this cosmic twirling and heating up caused some serious forces to come into play. It's like when you spin around so fast that you feel like you're about to take off. These forces led to the formation of rings of matter, like cosmic hula hoops. And as these rings cooled down, they transformed into planets and satellites. Now, not everyone was convinced by Kant's wild idea of planet formation. Critics raised their eyebrows and started questioning the whole theory. They pointed out that Kant failed to address the origin of this primordial matter. Where did it come from in the first place? Moreover, he overlooked the source of energy that propelled these particles from a state of cold stillness to a frenzied cosmic dance-off. As creative as his theory was, it soon faced dismissal in the scientific community. In short, they said, "This can't happen." Nevertheless, Kant's theory was still a step forward compared to older beliefs about Earth's origin. Take the ancient Egyptians, for example. They believed that primordial spirits, often depicted with frog heads in their native artwork, were responsible for our planet's existence. Why frogs, you ask? Well, they associated the first substance in the universe with water, and frogs just love humid environments. So, out of that initial water, a primordial hill emerged, followed by the elements of air and moisture. Ribbit.